So now we've talked about our emotions, the types of emotions we have, what distinguishes emotion and motivation, and we've talked about how easily our brain forms associations between emotional information and other information in our environment. So now let's delve into how is it that we control our emotions. One of the primary ways we control our emotions is through executive control. Executive control processes reside in the prefrontal cortex of the frontal lobes. And this higher order cognitive control includes executing and planning actions to accomplish goals, maintenance and sequence of information, and executive control is housed in the prefrontal cortex, meaning that the regions of the brain that are involved in executing and planning actions or maintaining or sequencing information are in the prefrontal cortex. And very importantly, the prefrontal cortex can decrease the response of the amygdala. So if you engage in more effortful control in the prefrontal cortex, that will decrease the reactivity of your amygdala. And so this is some of the primary ways that we control our emotions. We will label them, we will come up with tasks, we will sort of organize our minds, sequence information, maintain content, plans things, so that if we get some negative information, then we'll plan in a way to address it. So this plan will then, reduce our negative emotion, and it will involve coordinated action on the part of your prefrontal cortex. So here's a view, of your frontal lobe right here, and your prefrontal cortex is this sort of front region, okay? Here's your motor cortex, here's your premotor cortex. Anything in this whole area right here, this front portion is your prefrontal cortex. This is a dorsolateral region, and this is sort of a ventral or orbitofrontal cortex region. And remember, this is returning back to some of the nomenclature that we learned in the beginning of the semester. Dorsal refers to sort of up, so this is the sort of uppermost portion of the prefrontal cortex. This is lower, and if you can see here another view, this is the ventral medial portion of the prefrontal cortex. So this basically means it's the sort of the bottom, and it's medial towards the middle. And then here you have the orbitofrontal cortex, which is also known as the ventral lateral prefrontal cortex, which again would be sort of the bottom lateral sort of towards the sides. And here is an inner view, inside view. So here's the prefrontal cortex here, here's the ventral medial prefrontal cortex here, here's some anterior cingulate we were talking about with regards to the regions involved in processing emotion in the limbic cortex. And so this prefrontal cortex houses executive functions that are critical for regulating our emotions and organizing our daily lives. So in this way, the prefrontal cortex acts much like a composer. It selects the best actions for current time, place, and context. The prefrontal cortex receives information from virtually all perceptual and motor areas and a wide range of subcortical structures. So it provides a really good infrastructure for combining the diverse sources of information needed for complex behavior. If you have damage to the prefrontal cortex, then you're going to have very marked deficits in maintaining information, organizing information, engaging in goal pursuit. And as you age, you can have loss of frontal lobe function associated with dementia. So you can have frontal temporal dementia that can, in particular, target the neural regions in the prefrontal cortex. So you can have a loss of these, and that can result in more disorganized behavior and problems with memory retrieval and maintaining information. And you can learn more about what happens when you don't have a frontal lobe on page 421 of your textbook. So thinking then in terms of how we control emotions, let's take a step back to how we express emotions. So if you recall, this is the definition of an emotion: a relatively brief episode of synchronized responses, including bodily responses, facial expression, and subjective evaluation that indicate the evaluation of an internal or external event as significant. So in this way, there are three components of an emotion. We have the autonomic response, which would be increased heart rate, and this would be mediated by the hypothalamus and associated structures. We also have cognitions. These are thoughts about the experience, and these thoughts, they occur within our cerebral cortex. And then we also have subjective feelings, happiness, fear, anger. Recognizing and feeling these feelings involves aspects, parts of the amygdala and parts of the frontal lobes. So if I were to ask what you are feeling right now, what you're feeling right now would be dependent upon context. So to give you the following example, what happens when you watch a horror movie or a psychological thriller? So your heart rate might increase, you might have sweaty palms, you might get really excited, it could affect your breathing, so you would have an increase in physiological arousal. What also happens when you talk to someone you find attractive? Well, it turns out that lots of similar things can happen. So you can, again, have sweaty palms, you can have increased physiological arousal, your pupils will dilate, your breathing might increase, your heart rate will go up. And if you work out in the gym, you can also have all of those same reactions. Sweaty palms, increased heart rate, increased physiological arousal. So why I give these examples is that how you are feeling right now, or what you're feeling right now, is highly dependent upon context. So your emotion depends on the reason you experience arousal. So because our emotion depends upon the reason that we experience arousal, then what our body does is it interprets the arousal that we experience based in a large part, on the context that we're in. And so if you recall, I believe in one of the earlier videos I gave the example of they've done an experiment where they've had people meet at various locations, and one of the locations is on the top of a suspension bridge. And I believe this is in San Francisco, California, and one of the other locations is on a street corner. And what they found is that participants rated the other person they were meeting as significantly more attractive if they met on top of this suspension bridge than if they met on a street corner. And so in that circumstance, what they were doing is that they were misattributing the arousal that they experienced from being up high on a suspension bridge to the person that they were meeting. And so then the emotions that they experienced were more in line with attractiveness and sort of positivity, because their brains basically said, okay, look, the reason that you're experiencing arousal is that this person here in front of you that you find attractive, and not the fact that you are on this suspension bridge. So quite often we will experience arousal or have some sort of bodily reaction to a particular event, and we might misattribute it to somebody else or something else. But the most important thing to learn from this is that what you feel depends upon what you think the reason you are experiencing arousal, why you're sad, why you get angry, or whether you get sad or angry, or whether you get happy or angry. All sorts of things is going to depend upon the reason that you think your body is experiencing a particular reaction. So when we're interested in controlling our emotions, then one of the ways that we control our emotions is by thinking about the context that the behavior is occurring in. So we can try to change the context to try to then change the emotion. So if you were, for example, to get an exam grade back, and at first you were very sad with your performance, and you were frustrated with yourself, and then but you were also frustrated with the professor for giving such a challenging exam. And so what you feel in response to the exam is largely going to depend upon this context. Are you going to be sort of sad and frustrated and angry at yourself, or might you be frustrated or angry at the professor. Well, a lot of that information will come from other people in the course. If you had found out that other people in the course had a much easier time than you did, then you might say, okay, well, this really indicates that I need to study a little bit harder. But if you found out that lots of people in the course had a challenging time or an even more challenging time than you, then one possibility is that you could think that, well, this is the exam was too hard, and that it's really the instructor that has sort of caused me to feel this way. Well, this stuff is really, really important because the emotions that you feel direct your behavior in certain aspects. So in deciding then what to do on subsequent exams, if you think that most of your performance on the exam was really due to the professor making the exam too hard, then you would probably be less likely to study as much because, oh, it's going to be too hard anyway, so I won't study as much. But if you were to think that you're sad and sort of frustrate your own performance so that you need to study more, then you'd be more likely on the next exam to study more, to try to avoid that negative outcome that you had experienced earlier. So I'm giving this as a bit of an example because it's a relevant example for how you, as a student, could encounter a circumstance like that. So I give this as an example too to illustrate how your own emotion that you have surrounding those circumstances is going to motivate you one way or another. And so you can control how motivated you are by also thinking about the emotion that you're experiencing. And so it's a opportunity to really be mindful of how your emotions about a particular event can influence what you do in a particular circumstance. So getting back into this idea of why you're feeling what you're feeling, and that you sort of need to interpret the arousal that you might be feeling in light of a particular context. This is a James-Lange view of emotion, and this is that physiological changes produced by the autonomic nervous system come first, and then the brain interprets these changes as an emotion. So in this, the brain is an interpreter. The evidence of this is that the intensity of emotions in individuals with spinal cord damage depends upon the level at which the spinal cord is severed. So this is really interesting evidence that basically if you have spinal cord damage that's up closer to your neck, which would mean that most of your body is paralyzed, then your body cannot become as aroused. Because physiological arousal, of course, is going to have elements of heart rate, but you're going to have receiving sensory information from all over your body in terms of sweaty palms, stuff like that. So if a large portion of your body is paralyzed, then you're not going to be experiencing the same level of arousal as someone who is not paralyzed. And when you have these individuals that are paralyzed, then the intensity of emotions that they feel actually decreases. So you wouldn't necessarily think it, but someone who is quadriplegic, for example, the emotions are not going to be experienced as intensely. So as we talked about the amygdala already, that it's highly involved in forming associations. The amygdala also influences conscious awareness of the consequences of events and objects via connections with the prefrontal cortex. So this continues on this theme of forming associations, that the amygdala will give us signals and it will give us cues about what might be the significance of some of the arousal that we're feeling. So if you actually have amygdala damage, this can result in decreased fear response, indiscriminate sexual behavior, and the tendency to examine objects by mouth. So at a very basic level, if you have amygdala damage, then you're not going to be able to form some of the adaptive associations that would be helpful for guiding you in an uncertain world. We get all sorts of signals that we rely on, gut reactions, thinking of whether someone is thinking about doing something bad, a particular person that might be trying to swindle you. So we get all sorts of gut reactions and feelings, and those gut reactions and feelings, those associations, oftentimes they're signaling something to us that is real and valid, and that they often also reflect an association that our amygdala has made between a particular stimulus that we are interacting with, person, animal, whatever, and some sort of potential outcome. And so this will then guide our behavior. It also tells us what behavior is relevant or appropriate in certain contexts. So in addition to having sort of decreased fear responses when we might need to, it's also highly likely that individuals with amygdala damage are going to be less likely to exhibit appropriate emotional behavior. So I've worked in the past with individuals with frontal lobe damage and amygdala damage, and they both can respond quite differently, but the amygdala patients actually exhibited on the whole sort of the most inappropriate behavior. So we had a particular patient that had come to the lab and participated in the studies, and then we paid him, and I think it was like $50. And I was a graduate student at the time, and he was probably in his late 40s, early 50s. And so he turns to my colleague and myself after we pay him, and he says, so, you want to go out to a bar? I've just, got $50 here. We could go spend it together. And so that, of course, is not really appropriate. And so we had to say that, we actually have sort of more of a patient-doctor relationship in the sense that, you are participating in the study. It's not appropriate at all for us to engage in that type of behavior with you. So we had to be careful of our response, because it's not like someone came up and sort of hit on us where we could be like, are you kidding me? Hell no. No, we actually had to be engaged in really appropriate behavior that would be reflective of the type of medical or doctor-patient confidentiality relationship that we have as someone who's participating in a medical study. So, but the patients will oftentimes, with amygdala damage, will engage in some behavior that's a little bit unusual, that they might say or do things that would be inappropriate, not in the correct context, and so they don't have some of the signals that would be used to say, okay, you know what, we might not want to say this here, or something like that. Now, as I just alluded to, I've worked with individuals that also have prefrontal cortex damage, and when you have damage to the frontal lobes, this can have severe effects on social and emotional behavior. Your frontal lobes, they're not just the seat of executive control, but they are a huge part of your personality, the way you think about things, the way you organize information. So if you have damage to these, then it can cause a profound change of personhood and self. So people that have prefrontal cortex damage have an inability to experience and express their own emotions and to recognize the emotional expressions of others. So they are less likely to report the emotions they experience. They're less likely to recognize when someone else might be sad or angry at them. They can have apathy or loss of initiative or drive, meaning apathy is they really just don't care about anything, and they're not really motivated to achieve anything. They also can have problems with planning and organizing. This can lead to very poor decision making, increased rates of bankruptcy, heightened debt, not realizing the consequences of behaviors, much higher rates of incarceration or being charged with crimes. And if you've seen the movie One Flew Over the Cuckoo's Nest, which if you haven't, I highly recommend. And here is a link that I'm going to present to you that talks a little bit about frontal lobe damage. Before I begin the movie, I do want to say that viewer discretion advised on this link, that you can stop it at any time if you find it uncomfortable. You can look away. It talks about a period of time where, just as in One Flew Over the Cuckoo's Nest, that frontal lobe lobotomies were viewed as something that could provide a relief to depression and erratic or irrational behavior, and so parts of it are a little bit graphic. If you don't want to watch this video at any time during the lecture, then you can stop it. You can fast forward. Parts of it are quite poignant and should just be watched mindfully.
He was an idealistic doctor, hungry for fame, who would champion one of the century's most infamous medical procedures.
He wanted to solve the problems of psychiatry, and he wanted to do it fast.
The lesson here is not how a man can go off the rails, but is how science can go off the rails.
Ellen Ionesco was the first patient to undergo a procedure Dr. Freeman had perfected only weeks before. He called it transorbital lobotomy.
In a transorbital lobotomy, Freeman would first have the patient rendered unconscious through the use of the electroconvulsive shock machine.
Just before he threw the switch, we all had a laying on of hands and went for a little ride.
Usually 3 successive convulsions are necessary, but in old people a single one may be sufficient, while in a sturdy young person 4 or even 6 convulsions may be administered without danger.
The patient would then enter unconsciousness for a relatively brief period, but several minutes.
Now that the convulsion has subsided, the nurse holds a towel over the nose and mouth of the patient.
Freeman would peel back each eyelid, insert his ice pick, and with a hammer, tap through the brain, wiggle it about, sever the frontal lobes, withdraw it. And when the patient came to, he or she would be given dark glasses to hide the black eyes they'd been given.
We didn't have a refrigerator, we had an ice box. The first ice picks came right out of our kitchen drawer, and they worked like a charm.
Turning now to the operation itself, very little preparation is necessary for transorbital lobotomy.
The instrument was put in above the eyeball and in the plane of the nose. You could feel it hit the roof of the orbit, and then with a tap of a hammer you could knock it through. The whole thing would take 3 or 4 minutes.
This patient came to the hospital this morning after breakfast, and he will leave tomorrow afternoon.
There are reports which he proudly writes down in his diary about fellow professionals fainting as he proceeds in this, or vomiting.
Dr. Watts didn't say anything. He simply turned around and walked out. Spurred on by Freeman, the number of lobotomies performed annually soared from 150 in 1945 to over 5,000 in 1949. Despite the known side effects, there seemed to be an endless supply of willing patients. Ultimately, the fate of lobotomy would be settled by a pill. In 1954, a new drug called Thorazine began to sweep through state mental hospitals.
Thorazine was initially marketed as a chemical lobotomy. I mean, this was seen as a selling point, that it produced results similar to lobotomy, but without, of course, all the risks of the surgery.
Freeman decided to move to Los Altos, California, to resurrect his career. Far from the reproachful Eastern medical establishment, he could try to bring lobotomy to new categories of patients.
If housewives found their early 1950s existence too depressing for words, why, Freeman had a solution that would get them through their day happy as little clams. If children were misbehaving, conditions we might now see being called hyperactivity disorder, why they might need a lobotomy.
In all, Freeman lobotomized 19 children under the age of 18, including a 4-year-old. By 1967, Dr. Freeman had personally performed more than 2,900 lobotomies. In February, at Herrick Memorial Hospital in Berkeley, he performed his last when a patient died of a brain hemorrhage. Freeman was stripped of his hospital privileges and soon retired from his medical practice.
All right, so you made it through the video, and it's really, aspects of that video are really just horrible, but I show it because there are things that happen wrongly so that we can learn about really what not to do and how critical a certain structure of the brain is. science used to be really messy, and now we have all sorts of ethical guidelines in place that really protect individuals and protect people, groups of people, but this wasn't always the case. From everything from experimenting on prisoners of war, experimenting on people from the concentration camps, frontal lobe lobotomies. Lots of frontal lobe lobotomies were performed on inmates in mental institutions. And so these people really didn't have advocates. They would act, sort of bizarre behavior. They would oftentimes have real issues, and no one knew how to do anything with them or do anything about them. And so this really difficult and challenging period is one that we can hopefully look back on and learn a lot about how research and medical procedures should be conducted. There's lots of procedures in place to ensure that individuals are more protected when they are engaging in medical procedures, and as much as we can. These frontal lobe lobotomies in a very modified form are still being done in cases of excessive obsessive compulsive disorder. So this would be obsessive compulsive disorder that would be treatment resistant, that would not respond to any medications. Obsessive compulsive disorder is almost like being too rigid and excessive in the associations that you form. So the amygdala is highly involved in association forming, so you would form associations between your amygdala and your frontal lobe. And so what those procedures would do would be to try to sever some of those really strong connections, to almost sort of like free the person from sort of their own behaviors. And those would not be done sort of willy-nilly as they are here. They would be done in sort of a very, very controlled fashion, being very mindful of what type of connections need to be maintained and what type should be, so the connections should be broken so that the person is not always trying to maintain bizarre, obsessive, and compulsive, and checking and rechecking, and bizarre twitching behaviors, some things that are representative of extreme obsessive compulsive disorder. That the disorder is so debilitating that you need to consider brain surgery. And I also want you to think about frontal damage and what you've learned about the effects and consequences of frontal lobe damage, and think about why frontal lobe damage might be more common among prisoners. So now I want you to think a little bit about why frontal damage might be more common among prisoners. Think about how you get frontal lobe damage. And when I mean frontal, I don't mean frontal lobe lobotomies, but accidents, things that can damage your brain, and what, based on what we've talked about so far in this chapter and in this course more globally, what would happen when you have damage to your frontal lobes and how it would affect your behavior. And there is a participation question posted in which I would like you to respond to this question. Why do you think frontal lobe damage is more common in prisoners? And post your answer. And then after you post your answer, you'll be able to read what some of your classmates wrote in response to the question as well. So this is the end of this video. And as this video finishes, I'd like you to go and complete the posted participation question. You can complete the posted participation question at any time. I recommend doing it now while the content is fresh in your mind. And then after you finish, please feel free at any time to move on to the next video series or the next posted video for this chapter.